Okay, so let's take a look at this question. When will we see complex solutions? So we've watched all these videos about this imaginary unit I and complex numbers. Well, when are we going to use them? Okay, so first of all, it's important to understand the difference between a complex number and just the plain old imaginary unit I. So the imaginary unit I or a complex solution, an imaginary unit I is part of a complex solution, and we will use complex solutions when we're solving quadratic equations where the graphs never cross the x-axis. So that means we have no x-intercepts. That's when we're going to see complex solutions. But the imaginary unit I, we need to make sure we understand that first before we understand a complex number or a complex solution. So remember we said the imaginary unit I represents our square root of -1 because we don't have a value for that in the real number system. So we have to give it a name, and we call it the imaginary unit I, and it lives in the complex numbers solution or the complex number system. From there, we also know that I squared is equal to -1. So those are the two main definitions we need to know about the imaginary unit. I is the square root of -1, and then if we have I squared, it's just -1. Okay, now let's talk about a complex number. A complex number is complex because it has both real and imaginary numbers together. So if we look at a plus bi, for instance, something like 3 plus 5i, the 3 and the 5 are real numbers, but then the I is the imaginary unit. So when you put that all together, you get something called complex. All right, let's look at the first example. We have the square root of -9. So anytime you see a negative radicand, that's the number under the square root sign. So anytime you see a negative number under your square root sign, you want to break it up into the real number 9 times the negative number 1. 9 times -1 is the same as -9. But by breaking it up as 9 times -1, then I can really see and identify my need for the imaginary unit. So if I have the square root of the product of two numbers, I can rewrite it as the product of the two square roots. So the square root of 9 times -1 is the same as the square root of 9 times the square root of -1. Well, we know the square root of 9 is 3. And now we use our imaginary unit to represent the square root -1 as I. So my answer to this is just 3i. So just like the square root of 9 would be 3, now I have the square root of -9 would be 3i. All right, let's look at part B. The negative sign out front means I have -1 times the square root of -7, but I'm going to write it as 7 times -1. So I have -1 times the square root 7 times the square root -1. This is -1 times the square root 7 times I. So since 7 is not a perfect square, I'm just leaving it as square root of 7. Now, I'm going to bring the I to the beginning of the problem. So this becomes -1i times square root 7, or just -I square root 7. All right, and let's look at part C. Hopefully you're getting the hang of it now, so you recognize that this would just become 3 plus 7i over 2. And the reason I was able to make the jump to 7i is because the square root of the square root of -49 would be square root 49 times square root -1, and that would give us 7i. So my answer here would be 3 plus 7i all over 2.